Find the remainder when 171 multiplied by 172 multiplied by 173 is divided by 17. This question has been asked in RRB Group D in 2022. It's a simple solution. All we have to do is to divide all these three numbers by 17 individually and find the remainders. So 171 divided by 17 gives a remainder of 1. 172 divided by 17 gives a remainder of 2. 173 divided by 17 gives a remainder of 3. And the final step is, as asked in the question, we have to multiply all the reminders. So 1 into 2 is 2 and 2 into 3 is 6. So hence the remainder is 6 and the given option is C, which is the right answer. Thank you and subscribe for more.
If 7-digit number 504x5y3 divisible by 11, then one of the values of some x and y is. This question has been asked in RRB NTPC in 2022. In the question they have asked whether it's divisible by 11. We have to check whether the given value is divisible by 11 by following the divisibility rule of 11. If the difference between the two values is 0, then it is divisible by 11. Let's check that out. So in the question 504x5y3 is given. So 5 plus 4 plus 5 plus 3, which is the odd places, have been added together and 17 is the answer. And in even places, 0, x and y all together comes as x plus y. 0 is not considered because it's 0. So therefore the value of x plus y gives 17. From the question, it is understood that the given value has to be divisible by 72. So the first step will be the divisibility rule of 72. So it says that the given value has to be divisible by both 8 and 9. For the given value to be divisible by 8, the rule says the last 3 digits to be divisible completely by 8. Given last 3 digits is 5k6 from the question. So when we substitute k as 3 and try the value as 536, hence it is divisible by 8 and the question is 67, remainder 6. Next step is to find whether the given value is divisible by 9. The divisibility rule of 9 says if the sum of all the digits are divisible by 9, then it is divisible. The given value has p and k in it. We have already substituted k as 3 and now we are going to substitute 2 as p. After substitution, if you sum up all the given digits, you get 54 and it is divisible by 9, giving a quotient of 6. As seen before, substitution of k as 3 and p as 2, 3k plus 2p becomes 3 into 3 plus 2 into 2 equals 9 plus 4 equals 13 is the final.
If the 15-digit value is divisible by 9, then find the value of A. All we have to do is to make sure the given value is divisible by 9. Now we have to follow the divisibility rule of 9. The rule says we have to add all the digits and divide by 9. If the added digits is divisible by 9, then therefore the whole value is divisible by 9. So this is a given value and we have separated A from the whole value. And when we are adding all the digits, we get 72. And when you divide 72 by 9, you get 8 as quotient. In the question they have asked the value of A. So therefore the value of A shall be 8. Thank you.
They have given two 8-digit value and first 8-digit value has to be divisible by 88 and second 8-digit value has to be divisible by 9. And we have to find the maximum possible value of 3x plus 2y minus z. So if you look at the x and y lies in the first value and z lies in the second value. Let's look at the first equation. It should be divisible by 88. This is the first equation. So the divisibility rule of 88 states that it should be divisible by both 8 as well as 11. For divisibility rule of 8, the last 3 digits should be divisible by 8. The divisibility rule of 11 says that when the difference between the sum of odd and even digits is 0, it is divisible by 11. When we come to the second part, the given numbers are this. So when we add all the numbers together, 26 comes and the remaining z also comes too. So when we try to substitute 1 with z, hence it is divisible and the values of x, y, z is found. When you substitute all the three values in the given equation 3x plus 2y minus z, you get the answer.